Dear students, in today's lecture, we shall learn about a certain type of logarithmic functions, which is known as natural logarithmic functions. These are a certain type of logarithmic functions, as we already know. However, the main thing is that the base of log in these logarithmic functions is equal to e. And we should know the value of e, it is 2.71828. So when the base of the log is equal to the value of e, the logarithm which we usually study, which is known as common logarithm, is not common logarithm anymore. We call it natural logarithm. And there is a certain notation for that, which is ln in small case, and log is not used in case of natural log. And base is not written in this case because it is understood that the base is e. Now, if we try to recall the laws of logarithm, they are also similar in this case. Natural logarithm follow the same sort of rules that we know about the common logarithm. As you can see on this slide, the laws of natural log, they are no different from the ones that are of common logarithm. When we are taking the sum of two logs, the logs of the two values, they result in the product and then there are log. And in the same way, we can have the difference of the two logs written in this way, that is the natural log of their quotient. And the exponential law also helps us because it tells us that b can be shifted before log when we try to solve it. So in this way, we can apply the rules of common logarithm on natural logarithmic situations as well. There is an example from economic theory, and that is a very famous one. For example, Cobb-Douglas production function is a very commonly used type of production function. And this is how it looks like when we study it, that output is a function of labor and capital. However, there are some parameters involved in this case. Now, this set of parameters, that is beta 2 and beta 3, they are not known in the numerical sense. Therefore, we cannot say that this is a linear function. Most likely, this is a non-linear function. And non-linear functions are not the desired situation when we are doing analysis. Therefore, we wish that we could transform it. And natural log can help us. If we take natural log on both sides, we shall get this result, which is based upon the laws of logarithm that we just studied. And this is how the function will be logarithmically linearized by using natural logarithm. And these parameters, they have their own interpretation as the Cobb-Douglas production function requires. It says that if the sum of these two parameters is equal to 1, we can expect CRS from the production function, which is constant returns to scale. And if the sum is greater than 1, then increasing returns to scale. And if beta 2 and beta 3, they sum up to a value which is less than 1, we can expect DRS, that is decreasing returns to scale. So in this way, it is easier for us to understand a function which is not linear, and we can take the logarithm of that in order to make it a function which is linearized, and it can also give us more meaningful values. For example, if I shed light on this beta 1, beta 2 and beta 3. If we talk about these beta 1 and beta 2 in its logarithmic form, not in the form which is up there, rather in this form, which is logarithmically linearized. Now, these beta 1 and beta 2 are actually representing the respective elasticities. And that elasticity is of the output with respect to labor and then output with respect to capital. So this is how the transformed form is even more productive and useful when it comes to economic application and interpretation.